Okay, next problem. Find the intervals on which the following is increasing, decreasing. Identify the function's local extreme values, if any, saying where they're taken on. Which of any of the extreme values are absolute? Note in the homework they look at the endpoints. Okay, so we read things about increasing, decreasing, local max min, different textbooks, relative max min, whatnot. When you read those instructions, they trigger these steps. Find the derivative, find the critical numbers, make a sign chart. Those are my steps I'm going to follow each time. So, step 1. And let's remind ourselves that this is the same thing as sine x quantity squared minus cosine x. So my first derivative, using the chain rule, multiply by the exponent, decrease the exponent by 1, derivative of sine is cosine, then the derivative of cosine is minus sine. So my first derivative comes out to be 2 sine x cosine x plus sine x. So there's my derivative. Check your derivative twice, 3 times. If the derivative is wrong, everything else will be wrong from here. Check your derivatives. 2 critical numbers. Only on the interval 0 to 2 pi. So I set my derivative equal to 0. And I solve. Trig equation. This factors. So I'll factor out a sine x. Then it's factored and equal to 0, so I can split that up. So that gives me sine x equals 0. And 2 cosine x plus 1 equal to 0. I'll go up here and finish that. That gives me sine x equals 0. And cosine x equals negative 1/2. Then you're asking yourself, for the first one, what angles on the unit circle from 0 to 2 pi have a sine of 0? And that turns out to be 0, pi, and 2 pi. If you don't know those primary unit circle angles, you need to learn them. You can go Google unit circle, click on images, there are all sorts out there. I'm sure I have one posted in my lab math somewhere. Get a unit circle, learn it. Same thing here. What angles on 0 to 2 pi does cosine equal negative 1/2? And that happens at 2 pi over 3 and 4 pi over 3. And I'm just going to write here, note where f prime does not exist is not applicable. Now you wouldn't have to write that down, but we do need to remember that there are 2 types of critical numbers. One of the most common mistakes is people forget about that second type of critical number, and then when that second type, where the derivative doesn't exist, is in the problem, that mucks up the entire problem. But here, that's not applicable. So now I'm going to make my sign chart. I'm going to split up 0 to 2 pi, because they told me just to go to 0 to 2 pi at each one of my critical numbers. Now, I kind of left out 0 and 2 pi are also in the list of the critical numbers, so we just have a little less to work with is all. So I'm going to start at 0, go to my smallest critical number, which would be 2 pi over 3. Then from 2 pi over 3 to my next critical number, which would be pi. Then from pi to 4 pi over 3. Then from 4 pi over 3 to 2 pi. And again, if you don't remember the relative positions and things, get the unit circle, memorize what it looks like. Then we pick a test value. So any angle between 0 and 2 pi over 3, and I'm going to pick pi over 2. Anything from 2 pi over 3 to pi, And I'm going to pick 5 pi over 6. Anything from pi to 4 pi over 3. And I'm going to pick 7 pi over 6. And anything from 4 pi over 3 to, from 4 pi over 3 to 2 pi. And I believe I can pick 3 pi over 2 there. And again, if you don't know your unit circle, get a unit circle and know those values. Now, another thing you could do, you could change these all to decimal values here. Now, don't give me decimal values for your answers, but you could change all these to decimals. You know, for example, 2 pi over 3, 2 pi divided by 3 is roughly 2. 2.09. So this is roughly 2. And so you could pick a number between 0 and 2 here. And all the way down. This is roughly 3. So pick a number roughly between 2 and 3. That you can pick decimal values here. Just don't give me the decimal values for an answer. But I'm going to do that. And then we plug into f prime. Now you can absolutely use your calculator here. You don't have to do this in your head. You can use your calculator. And here's how we're going to use our calculator. Press y equals, type in the derivative. So the derivative was 2 sine x cosine x. So 2 sine x cosine x plus sine x. Type it in there. Okay, I do make sure, I'm going to press mode here, make sure you're working in radians. That's important. You cannot be working in degrees. You have to be working in radians. So I put my derivative into y1. Clear this. Now to easily make your calculator do this, I'm going to press vars. Then I'm going to arrow over to y vars. Then I'm working with functions, so I'm going to press 1. And then I put my equation into y1. If for some reason, if you put your derivative into y2, you'd press 2. If you put it into y3, you'd press 3, whatever. But I put it into y1, so I'm going to press 1. Then I'm just going to put in the value I want. I want pi over 2. So y1 of pi divided by 2. And so what it's going to do is it's going to take pi over 2, it's going to put it in my derivative and tell me what that answer is. And it tells me that that answer is 1. And so this is positive. We're going to start all the way over, do the whole thing again. So you're going to press y equals, type in the function. We did that. Then just for practice again, you press vars, arrow over to y vars. We're working with functions, so number 1, and then you put it in y1, so number 1. And then you put in your value. 5 pi over 6. So 5 pi, forgot the parentheses, 5 pi divided by 6. Yep, that's what we had. Enter. And that comes out to be negative. Now you do not have to type that entire key sequence all the way down. If you ever want to just change, we would essentially want to do the same thing, but we don't want 5 pi over 6. If you really just want to edit the previous line, you can do this. Second and entry. That gives you your previous line, and then you can just go back and type what you want. That I want 7 pi over 6. So instead of that 5, I want a 7. Hit enter, and that comes out to be positive. And again, this time I just want 3 pi over 2, second, and enter. It turned itself off, so let's turn it back on. Second, and enter. Well, this is problematic. Let's try it one more time. Second, and enter. Okay, my calculator is not working for me, so we'll do it the long way. Vars, Okay, my calculator is apparently dying. I guess I should have changed the batteries. So we'll do it the hard way. 3 pi over 2. So if I put 3 pi over 2 here, notice sine of 3 pi... Oh, never mind. I had lost my train of thought. Cosine of 3 pi over 2 is 0. So this first part's going to be 0. Cosine of 3 pi over 2 is 0. If I put 3 pi over 2 over here, sine of 3 pi over 2 is negative. And so that whole thing is going to be negative. Then once I have my chart done, I can say that f of x is, my function is increasing, or is positive, so it's increasing, decreasing, increasing, and decreasing. Positive derivative means my function is increasing. Negative derivative means my function is decreasing. Positive derivative increasing, negative derivative decreasing. And then from there, I can tell where I have local maxes or mins. That at 2 pi over 3, I go from increasing to decreasing. So there had to be a maximum there. So if your derivative changes from positive to negative, or your function from increasing to decreasing, you have to have a max. Here, from 0 at pi, I change from negative to positive, my derivative changes from negative to positive, or my function changes from decreasing to increasing. Well, the only way that can happen is if you had a minimum, and you pass through a critical number. And here we pass through a critical number. The function changed from increasing to decrease, or the derivative changed from positive to negative, or the function changed from increasing to decreasing. And so that had to be a maximum. That's the only way it can be. So then kind of summarizing here, this function is increasing on the interval 0 to 2 pi over 3 and pi to 4 pi over 3. It's decreasing on 2 pi over 3 to pi and 4 pi over 3 to 2 pi. We have a local maximum at x equal 2 pi over 3. With y equal f of 2 pi over 3. Go out a little bit. Y values always, always, always come from the original function. And so this was, let's put a little recall here, that the original function was f of x equal sine squared x minus cosine x. So my y coordinate here is going to be sine of 2 pi over 3 squared minus cosine of 2 pi over 3. And now here, your calculator would tell you a decimal value, but you aren't going to get full credit for a decimal value. Sine of 2 pi over 3 is square root of 3 over 2. Cosine of 2 pi over 3 is negative 1/2. So I've got 3/4 plus 1/2. And what that's 2/4. So that'd be 5/4. And so the point 2 pi over 3, 5/4 is going to be a local maximum. We'll continue on with this problem on the next video.